Hey everyone, welcome to this webinar, the 2022 State of DevOps Report Takeaways. We'll cover the webinar and what we're going to talk about in just a minute. But before we do that, let's cover a couple of practical things. First of all, if you have any questions during this webinar for any of the presenters about the technologies, about the reports, just ask them in the chats. We will try to answer as we go along, or at the end of the session, we'll see when it makes most sense. A question that is often asked is whether the session is being recorded. Yes, it is. It's going to be available on YouTube. The URL you're currently seeing in your browser is the place to be, and we'll also make it available afterwards through our newsletter, through other channels, and so on. And with that, let's bring in our other guests, and let's talk about the State of DevOps report as well. So welcome, Marco. Welcome, Nathan.
Hello, Maarten.
All good with you guys?
Yes, I'm excited.
Yeah,
all
absolutely.
Right. Then let's not waste any time and let's dive into the State of DevOps reports, Nathan.
Yeah, great. So hi, everyone, and thank you so much for having me on today. I really appreciate it. My name is Nathen Harvey. I'm a developer advocate with Google Cloud and part of the DORA research team. Now, you may have heard of DORA, but maybe not the DORA that I'm thinking of. The DORA I'm thinking of stands for DevOps Research and Assessment. That's the DORA that I speak of. This is a long-running research program that really seeks to answer this question: how do teams get better at delivering and operating software? And our research is academically rigorous, and very importantly, it is program and platform agnostic. We really look at how teams are doing and try to understand what lessons can we take from teams across the world in every industry, teams or in organizations of every shape and size. And each year we publish a report. We call it our Accelerate State of DevOps report. And I'm so very happy that, JetBrains was one of the sponsors. The 2022 report is out. It's available now. While I can't hand you a copy, although I'd love to, you can download it from the URL that's right there. So cloud.google.com/state-of-DevOps. And so I think we wanted to go into some of the key findings from this year's report. So first, when we think about DevOps, I think we have a big challenge in front of us. DevOps is a word that a lot of people use, and almost everyone has their own definition for that word. In fact, some people have multiple definitions for the word. So across our three panelists today, I bet we could come up with 5 definitions for the word DevOps.
I guess we can fill the hour with
definition. But let's not do that. Let's talk about how do we measure DevOps and measure performance with our State of DevOps report and with this research program. And we really look at 3 big areas of performance: delivery performance, software delivery performance, that is, operational performance, and organizational performance. So on the software delivery performance, we look at 4 key metrics for software delivery performance. And these metrics fall into 2 categories: throughput and stability. On the throughput side, we're really looking at what is the velocity of change for your organization or for your team. And so we look at things like your lead time for changes, from the time a change gets committed to the version control system until that change lands in production. And then we also look at your deployment frequency. How frequently are you pushing changes out and making them available to your users? And these are 2 good metrics that really help us understand how big are the sizes of the changes that we're pushing out, because we want smaller and smaller changes. Now, it's all well and good to move fast, but to move fast and ship where things break all the time, maybe not so good. Your customers won't be so happy. So we have to look at some stability metrics as well. And on the stability side, we look at your time to restore service. So if let's say you push a change into the production environment and something breaks, how quickly do you and your team respond and restore service for your users? And then finally, we have the change fail rate. I like to call this the expletive rate, because it's what happens when you push a change to production and then someone shouts out an expletive. Something has gone terribly wrong. We need to roll this back or push a hotfix forward, something like this. Now, taken together, these 4 metrics for software delivery performance can be used for basically any type of technology that you're building, operating, delivering to your customers. That technology could be custom-built, homegrown applications. It could be machine learning models that you're shipping off to production. It could be mobile applications. It could even apply to mainframe applications, any type of technology. The other important thing about these 4 metrics, though, is that we have to take ownership and accountability for them across the entire cross-functional team that's responsible for this application. We can't do like we did in the old days, where we turn to developers and say, you're responsible for those throughput metrics. And then we turn to operators and say, you take on those stability metrics. When we do that, we set up some fighting and some perverse incentives across them. So we really need the team to share these together as collective goals. So those are our software delivery performance metrics. And what we want to do, of course, is get better across all 4 of those. But once you've shipped software or shipped a change into production, now we have this other question of how's your operational performance? And for operational performance, we look at reliability. Now, the unfortunate thing about reliability is it's not a thing that's super easy to measure, because, I can certainly tell you whether or not your systems have been up or if they're down, but reliability is much more nuanced than that. So we have to look at a multifaceted view of reliability. But at the end of the day, the answer, or the question that we're trying to answer around reliability, is, are your services meeting the needs of your customers? Are you meeting their reliability expectations? Are you keeping your promises to them? And so this is our reliability metric. Are you able to meet the promises that you've made to your customers? Now, I talked about a third metric, organizational performance, and really what we've shown throughout the body of research that we have over the past 8 or 9 years is that these metrics, software delivery performance and operational performance, are predictive of better organizational performance. Organizational performance also is very context specific. Are you a public organization that's trying to serve your citizens or your constituents? You have very different goals than, say, a for-profit organization. But in either organization, your organizational performance matters, and these metrics can help drive that. So those are the ways that we measure DevOps. So forget the label. Here are the measures that are important. Well, now that we've sort of laid that groundwork, let's go back to the report. Let's talk about some of the key findings there. The first key finding, and this is the most important, context matters. I'd love to sit here and tell you to find and achieve success, follow this exact roadmap, follow this well-paved path that's worked for every other organization, so it's bound to work for yours. But the truth of the matter is that's not how it works. We have to think about our own teams. What are our teams doing today? What capabilities are they making use of? What capabilities are they good at? What capabilities could they improve? And when it comes to capabilities, we, in our research program, look through a number of different capabilities. We look at technical capabilities, of course, but we also look at things like process capabilities and cultural capabilities. We really try to take a full picture of how a team is working together. And all of that context really matters. But through the research, we're able to make some predictions, draw some connections between capabilities and those outcomes, those measurements that we talked about. And in our research, we've looked at that organizational performance, as I talked about. We see there are 3 big drivers that are predictive of better organizational performance. In addition to those metrics that we just talked about, we also see culture playing a significant role in whether or not your organization is successful. But along with that, reliability, so of course those operational metrics, but we also see some signals that taking proper advantage of cloud and cloud infrastructure is predictive of better organizational performance as well. Now, I mentioned this was a program and platform agnostic study, and now I'm mentioning cloud. Is that really program or platform agnostic? Well, it is actually, because the way that we look at cloud is not specific to any one cloud provider or even public or private cloud. It really comes down to those capabilities. So for example, we measure cloud on your team's ability to give developers self-service access to an environment, your team's ability to scale up or scale down elastically the compute resources that you have. That doesn't necessarily tie you to a particular cloud provider. It is definitely open. And then finally, the thing that we dug into this year, and because we've had years and years of research here, we get to select, or we identify an area where we want to go deep each year. And so not surprisingly, maybe this year, we dug deep into supply chain security and specifically software supply chain security. So as we're bringing in more and more software artifacts into our own development environment, how does that work for us? And one of the things that we saw was that adoption of some of the capabilities around software supply chain security, they're already happening. Teams are adopting these practices and these capabilities today. Of course, there's a lot of room for improvement and a lot of room for teams to grow, but it's a good thing that we've taken the first step. Then the next thing about that software supply chain security is that we've seen some real benefits to this. In fact, some unexpected benefits. So of course, we expect, and you would expect, that as teams get better at supply chain security, they're going to have more secure systems. Check. We found that in our research. But what we also found, interestingly, was that teams that are adopting these practices and capabilities tended to have lower burnout on those teams than teams that are not adopting those practices. And this is a somewhat surprising finding or an unexpected benefit that we saw from adopting these practices. But honestly, if you think about it for a couple of minutes, it makes a lot of sense. If I'm running systems that I know are insecure and I don't have a good way or a good path to secure them, I'm going to stress about that. And that may very well increase my burnout. It will certainly keep me thinking about those systems and worrying about them when I go home. Whereas if I know that I can easily patch a system, keep it secure, I can much more easily disconnect from work when that time comes. And so that will help alleviate or eliminate some of that burnout.
I guess it also means that you have fewer points where you dive into the expletives and where things break and people have to jump into everything.
Yes, exactly. A good measure of or a good measure of burnout. How many expletives do you hear around the office on a regular basis? Yeah,
Exactly.
it's those go up. Potentially, you're seeing burnout increase. Absolutely, absolutely. Now, with supply chain security, we also found a key integration point. In fact, because we have all of these different capabilities that we look at, we're able to draw connections across them as well as connections to the outcomes. And what we saw that were the teams that were embracing the practices around continuous integration, those teams tended to have better security practices. And not only does continuous integration lead to better security practices or more enable better security practices, the really cool thing that we found was that teams that tended to have higher than average continuous integration practices and higher than average security practices, those teams had the best organizational performance. So this stuff really matters. It matters to you. It matters to me as an engineer. I don't want burnout. I don't want to run insecure systems, but it also matters to the bottom line of my organization. So it matters to the CEO. That's pretty cool. And then finally, maybe the most important finding around software supply chain security was we found that healthier cultures tended to have the best software security supply chain practices. In fact, culture was the #1 predictor of those practices. And so how do we measure culture? Well, this is always an interesting question. Is your culture good? Did you get a free lunch today? That must mean your culture is good. That's not how we measure that. On the next slide, though, we'll see that we leverage research from a sociologist named Ron Westrum. And what Westrum has done is research into a ton of different organizations looking at how does culture work. Can you go to the next slide for me, Maarten? So there we go. Thank you. So the way that culture works and what he's discovered is this topology of organizational cultures. Now, just viewer, listener, thank you for joining us today. Just take a minute, have a look at this chart. Do you see your team and your organization somewhere along this chart? Look at it as a continuum. You might not fit cleanly into one of the 3 columns, but it's likely that you're pretty close to one. So do you find yourself as a power-oriented organization, a rule-oriented organization, or a more performance-oriented organization? Of course, we found in our research that those performance-oriented were generative cultures where information flows freely, where when there is a mistake, when there is a failure, we use that as an opportunity to learn and not as an opportunity to blame. These are the cultures that tended to have better security practices. This is a #1 predictor of those security practices, which I think is fascinating. I think that, regardless of what your definition of DevOps is, there's always a cultural component in it, or almost always. And if there isn't, I would argue that there should be, because this becomes so fundamental to all of the practices and capabilities that we want to put into place. And let's go on to the next slide then, Maarten.
All right. Yeah, I think the next slide and the rest of this entire webinar is talking about some of the practices that are discussed in the report, the SLSA practices. I think you pronounced the abbreviation.
Yes, SLSA. So when we looked at those security practices, we utilized two different frameworks. Just like when we looked at culture, we utilized the Western framework. When we look at security practices, we utilize two different frameworks, SLSA and SSDF. So SLSA stands for software levels for supply chain levels for software artifacts, and then the SSDF stands for the Secure Software Development Framework. So both of these are looking at how do teams get better at delivering secure software and managing the security of that software throughout their entire pipeline.
Yeah.
And so one of the practices there is history preserved. And Maarten, I think you have some things to say about that.
Yeah, I think this bridges nicely in what we do at JetBrains. So for the remainder of the webinar, we're going to try and talk about some of those SLSA practices and SSDF practices and link them to how you can implement them in your organization. And again, in that continuum between being very open and very communicative everywhere, it's an opportunity for your organization to grow, for your team to grow. And a lot of these practices can actually be solved by tooling and practices that are well written and talked about. So history preserved is one of those, where all of the revisions in your change history are preserved indefinitely. So what we're going to see is that there's tools to help you with that, but we're also going to link this back to how some of the teams at JetBrains do this and apply this to make our way that we build software better and more easy to work with.
I think that's really important, because as we have this research that is, program and platform agnostic, that's great. And I have some ideas about how do I put that into practice, but how do I actually apply that with my teams? And that's where it's really great to work with teams like JetBrains that provide that technology to really bridge sort of the academic research to the what am I going to do in practice every single day. And I'm really excited to share that you'll be sharing some of the ways that JetBrains enables that.
Exactly. So let's maybe start with that first one, history preserved. This is the part where people write code in your team, where your developers are building the software on their machine, on remote machines, wherever. It means that you probably have some centralized repository where all of the source code comes together. And in Space, which is our tool for software teams to work together to collaborate on their code base and build software, we actually have a built-in Git repository hosting that gives you all of the things that this history preserved aspect talks about. So you can browse the repository, look at the directories and files that are in there. You can see the full commit history, with who committed this, who was the author, what were the changes that were added. If you set up CI/CD, you can actually link that back to that commit history. So you get this end-to-end traceability from source code to artifact, but also the opposite way around, where you come from an artifact and see what code is actually included in this artifact. We also have commit signatures there, which is also feeding nicely into your supply chain security, where you can actually see that the author of a specific commit was really that author because it's signed with a digital and trusted signature that you have on your Space instance. So I think it's probably best explained in a quick demo. So let's maybe switch to my screen and then we'll have a quick look at what this looks like. So this is Space. There's a dark theme, there's a light theme. I thought for tonight, because it's already dark where I'm presenting from, let's go with the dark theme. But this is a Git repository in one of the projects that I have in Space. But let's maybe go to this one, because this one is a little bit bigger and a bit nicer to look at. So in the repository, what you will see is all of the files, all of the folders, and all of that are in there. You will be able to browse whatever is in that repository, see whatever is in that file. So let's open some random ones. I have no idea where we actually have codes, but you can quickly see what the code is there. More importantly is that on the top right hand here, you can see who actually worked on this particular file. So you can already see the initials of the people on your team that have been working on this particular file. And you can annotate that even if you want to see who has been working on this. So by maintaining that commit history in this Git repository, you can actually see who wrote a particular file, on what dates, and which commit was this part of. So you can see all of the related changes there as well. And this helps you in tracing who wrote a particular change, why was that change created, and things like that. The next thing we have here is this commit steps. And I guess everyone who has been working with a Git repository will be familiar with this. But the idea is that you get the full Git history of everything that happened in this repository. We want to preserve that history while you have it here in space, so you can keep scrolling until the beginning of times of this project and essentially find out what happened for the entire history of this project. So I can keep going. This project is 2 years old, so there's lots of commits in there that you can scroll through. Really nice here is again that you can see who wrote the commits. So you see names there. You also see this verified sign there that says, okay, this was a verified committer actually making this commit into space. And you will also see that there's this Ktor link that links back to utrack. Not sure if you can see it's down there in the browser status bar, but this is actually as part of every commit. We are adding an issue tracker number, and this links back and forth between space and the issue tracker that we are using, so you can see why a certain change was made. So not only can you see all of the changes that are in there, all of the author information, all of the automation and deployments maybe that are linked to this specific commits, you'll also be able to see what was this issue about, get some history, get some background. Maybe it was a customer that actually logged an issue. Maybe it was someone in the team who proposed a new feature that you are currently working on. So there's lots of things that you can do there in terms of keeping track of the history, but also keeping track of the why of everything that you have in your software there. Let's maybe talk a little bit more about this verified badge as well, because that's an interesting one. When you are committing to a Git repository, typically you set your name, you set your email address, and that's pretty much it. It doesn't give you any certainty of whether this user is actually who they tell you they are. So what you can do in Space and in lots of other tools as well is essentially upload signatures, create signatures, create certificates for every committer that is going to contribute to your repository, and then verify those on the Space instance that you have. So what you will see is that Leonid here has actually uploaded a certificate, and all of his commits are signed when they are committed into this repository. So that's really nice and really helpful. Now, Space gives you different gradations. You say it's a continuum between all of the different aspects and where you are on that on the level of DevOps that you're applying in your organization. So Space helps you grow there as well. In the settings for every Git repository, you can actually see that there's push restrictions that you can set. And right now, I just enforced that line endings are compatible and so on. But when you go in there and you want to enforce this supply chain security that you have by verifying commits, there's different gradations that you can apply. So if you enable verify committer, what will happen is that that Space on commit will check that the email address and the name of the person who is committing to this repository actually is known to the system. It's very simple. It's just based on the email address, so it doesn't give you full trust, but it is a step towards knowing who is committing there. You can also require that the commit is signed. This means that the commit has to be signed with this digital signature. The next thing is that you can also verify that signature. And this is really having to upload the signature into Space and being 100% certain that the commits actually come from the committer and the person who they say they are when committing into Space. So I think that's just a quick overview of how we adopt history preserved, or how you can adopt that when using tools like Space. And I think we can go back to the slides and maybe talk a little bit about how we do this internally in JetBrains for some of the teams that we have. So if you look at the Git repositories that we use at JetBrains, we have different products. We have the IDE line that is based essentially IntelliJ IDEA and all of the IDEs that come from there. We have Space, we have teamCity, we have all kinds of other products. For all of the IntelliJ-based IDEs, we're actually using JetBrains Space to host the source code that we have. And we are preserving the history since 2005. We've not always been using Git. We actually started with Perforce and Subversion, but we've tried to migrate everything, keep that entire history, and you can actually find the first commit to IntelliJ IDEA in our repository. I've been scrolling. It's a lot of scrolling, but you can find it and you can filter it if you want. It's about 20 gigabytes of history right now, or 20 gigabytes of sources that are in there, over 1 million commits, over close to 10 million lines of code in terms of Java, 300 to 400 active developers and past developers, future developers. So a lot of history and a very rich history with those interlinked issues and code reviews and so on that we have there. So at any point in time, if we are looking at parts of our codes, we can, first of all, if there's a link to an issue, we can see the reasoning behind why this change was made. But also we can figure out who wrote a particular line of code, who made a certain commit, what kind of changes were introduced, and find who actually owns that code, and maybe even track down the institutional knowledge that is nowhere written down, but figuring out who owns the code and who to talk to make things better, or get an explanation about why this thing is actually in code. So I think that is what is meant with history matters, and I think we're doing a good job, at least in the IntelliJ team, definitely, to track down all of those things that are in there. So I'm not sure if anyone wants to add something here.
I just wanted to add that, I'm from the teamCity team, to all the viewers out there, that the teamCity repository is almost quite as old. It's a bit smaller than the IntelliJ repository. Yeah, I just double checked. We have just a quarter of the commits, but roughly similar size and whatever. But it's a long history either way, spanning across more than 2 decades, essentially. It's crazy.
That is crazy indeed. I'm also going to add, we'll see later, the point we're doing the full circle back to the entire report and everything that has been going on. Having this history preserved is really valuable also to the operational excellence that you may want to apply in your team. Right, let's quickly move on and talk a little bit about dev environments. I'm not going to demo there, but essentially dev environments are yet another tool that might help you with preserving the history of the codes that you have. Dev environments in space let you run the IDE backend on a remote server in the clouds. You connect to it from a thin client on your machine, and you can use whatever cloud machine. So all of the benefits from cloud you would get with dev environments. If you need a GPU machine, you can get a GPU machine. If you configure a remote development environment on a different cloud, for example, you can work with powerful remote machines whenever you want and however you want. Now, this helps with security because the code is never on the developer machine. You have this thin client, you're working remotely. If the developer's laptop gets stolen, you actually don't have a copy of the code on that laptop and you don't have to really account for that. So it helps you with that security aspect, but it also helps you with preserving history. Because every single development environment that you create is essentially scripted using a Docker file, using a dev file that's sort of characteristics or tracks the characteristics of the virtual machine that you're working on. But the interesting thing there is that all of that is IDE or branch and commit specific. So that means if you want to go back 5 months in time, you can actually work with the IDE that the team was using at that point in time. So you also have that history. If you have to apply a hotfix, for example, you actually have a copy of the IDE because you scripted this, because you wrote that as part of the code base and have that in code. So you can also see how the development environment maybe evolves over time by preserving that history.
That's really cool. Just on that development environments, we're talking about preserving the history, but I also love the value that this provides in the future. As we bring on new developers to the team, their ability to get up to speed and have a development environment ready for them. I can't tell you how many, I don't want to say how many days I've spent getting my developer workstation configured exactly right so that it can work with the project. This is a huge jumpstart there.
Yeah, and again, it goes per branch, per commit, so it means you can go back and forth in history, but also if you're shipping a new version in a new branch, in a feature branch where additional tooling is required, you can just have that there and all of the developers will have it immediately.
And can those environments also write the code automatically for me in the future without me having to do anything? Oh, did I just go back in time?
We'll see what the future brings there.
Yeah, okay.
All right. I guess we can skip to the second SLSA practice that maybe makes sense as well, and that is the two-person review. I think Nathen, if you wanna elaborate on this a little bit.
Yeah, I think that this is a security practice where we want to prevent bad code from getting into production. And of course, we can do that by having others review that code and validate it before it goes in. This can help us potentially prevent some malicious code from escaping and getting into our production environment. But of course, there are lots of other benefits that you get when you have multiple people reviewing changes. You're not only preventing bad things from happening, you might be enforcing some standards, but also I think it's important to remember that you're also doing some knowledge sharing by having an additional person look at the code changes that are going in. Let's make sure our code changes aren't too clever, because I want to be sure that I can troubleshoot them at some point in the future as well.
Yeah, exactly. You want to have this nice balance between readability and clever. Yeah, correct. I think one of the tools, again, that can help you there is in Space, where Space actually comes with all of the functionality that can help you and your team to do code reviews. In code reviews, you can essentially discuss changes, keep track of all of the knowledge there, because maybe you do want to make sure that nobody's shipping this clever code, but you can also see the entire discussion when that discussion was held. So if at a later point in time, you see a commit where you have a review linked to that commit, you can actually go back, see that discussion, and maybe at that point in time, the clever code is actually more applicable. So you can still find that as well. In Space, there's two types of reviews that you can do. One is using the merge request or pull request flow, where you actually review changes in a branch before you change them to your, or before you merge them into your main branch. The other one is post-commit reviews, where essentially any developer can look at the commits in the entire Git history and start a review, discuss with the author, discuss with the team, whatever is going on there. A really nice addition there is that, yes, you can review the code, but you can also set some requirements on what code do you want to allow into the repository. So we already saw that you can enforce signatures and so on. That's the security aspect of things. But you can also enforce that, for example, 2 people have to review the code. You can enforce that at least 3 people of the team have to review the code. Maybe if you are doing the last week before a big release, maybe you want to make sure 10 people look at the codes. Anyway, you can set quality gates there to your liking and essentially configure them how you want. One that I typically enforce is that there's at least 1 review in lots of repos, and that people don't force push into the main branch, which means that all of the history gets lost and rewritten, because that is not what you want. You want to keep track of history and keep the history preserved again. So let's maybe switch to my screen again, and let's have a quick review of code reviews in Space and what you can do there. So again, this is one of the repos that I have in Space, and let's maybe do a post-commit review. At any point in time, I can look at a commit, see the changes there, and start a new code review. I can start a code review from here, or I can add it to an existing review. Maybe if you have multiple commits that you want to review in one go, you can also add them into a new review. But let's just start a new one, and let's see what happens then. What you will see is a timeline, essentially all of the discussion that happens. This is preserved with the review, with the chat history that you have. So anything that is discussed here, you can mention people from the team, bring them in. You can just discuss whatever is going on related to the changes. And of course, you can also look at the changes in there. You can add comments on a specific line, all of the typical review things that you may want to do there. So this is the post review, looking at random commits, asking questions about them, maybe trying to figure out, is this a bug? Maybe discuss with the team and the author whether something could be a bug or something like that. This is something that you can do there. Once a review is finished, of course, you can close the review. If you want to add reviewers, you can add them here as well, and just find random people in the team in this case to also have a look at this. But again, you will see the history. I added this reviewer, and they will be joining here and looking at whatever is going on in there. Right, I'm gonna close this one. Nothing really useful happening here. And let's maybe look at an existing merge request. This idea of having feature branches that you want to merge into your main branch. So here you see already some discussion with some commits that are linked. I can actually look at the changes and figure out what was discussed in there. So I think at some point there should be a discussion. There's no discussion in there. Anyway, I can add one here and say, let's maybe fix this to do as well and post this now. All of the people involved in this code review will see this, but also again, later in time, I will be able to see this entire discussion, see what was opened there. Now, in my review, in this timeline, you will also see on the right-hand side there that I have this quality gates failed warning, that I have one reviewer that is still reviewing the changes and so on. This is also very important metadata to not only preserve history, but also to enforce that people are actually reviewing. So in this repository, I configured some quality gates where I say, look, I require one approval from anyone in the company, because this is a small company demo application, but you could set this to a specific team, for example. I need one approval from anyone particular in this project, because that is also an enforcement that I did. And I also have one automated check. We'll talk about that in a little bit, about CI/CD, where I say, look, you can never merge from a feature branch into the main branch unless you actually have a working build there. Now, I'm an administrator. I can overwrite this and I can still merge, but you see everything is orange. I get warnings all over the place that this is not the way to go and something that you should not be doing. Let's maybe quickly go into the settings of this repository just to show you what type of quality gates you can think of. So under protected branches, you can actually configure the quality gates per branch that you have. So in this case, we have quality gates on the main branch where you say, look, whenever you want to merge or commit into the main branch, you may want to enforce linear history so that people actually squash and rebase instead of merging. That's one of the things you can do. You can also prevent force pushing, so nobody is allowed to force push into the main branch in this case. Maybe you want to also remove push access for anyone in the project there, because maybe only certain people can push or perform the merges into your main branch there as well. And then the next thing you can do is also configure the rest of the quality gates. So in here, I enabled that I require an approval from people mentioned in the code owners file. That's another thing that you can do, essentially specify this path is owned by this team or this person, and they will be added into the review. But also you can say, look, anyone from the software development team or from this company, I require one approval at least from anyone in this group. Also there, you can add CI/CD. So you can say, look, this CI/CD job actually has to finish before you are able to merge. And you can also add external checks using teamCity or something like that, where you can enforce that the build is actually green before you merge into mainline. All right, let's go back to the slides. Cool. So in JetBrains, we have code reviews. Again, you mentioned that context matters, and context definitely matters. Every team in JetBrains is doing this in a slightly different way, but generally we have code reviews where multiple people review the changes, comment on the changes, make suggestions, and so on. What we try to do in code reviews is not be very particular about code formatting and style guidelines and all of that, because you have tools for that, but really look at the code, why a change was made, and maybe force some additional thinking about what is going on in there. Another thing that we use is safe merge in JetBrains, where before you merge into the mainline, we actually do the opposite. We merge the main line into your feature branch, do a build, and only when that is green, we merge it into the main line, just to make sure that the main branch always has a green build that is that builds on every developer machine and in CI/CD. One interesting thought there is, should you be doing code reviews or should you be doing pair programming? And again, context matters there, I think, quite a bit. Merge requests and pull requests are typically something that you do after the change has been made. If you do pair programming or mob programming or things like that, you're actually, while you're developing, working with multiple developers on the same project and on the same problem. and you already kind of have reviewed code because there's multiple people sharing their thoughts while you're writing the codes. If you want to look at tooling there at JetBrains, we have Code With Me. This is a technology that allows most of our JetBrains IDEs to set up collaborative developments with built-in calls where you can do pair programming, swarm programming. If you have a classroom training, for example, and you want people to follow the main author, you can do all of that using this technology. Again, this very much matters on the context, I think, whether you do it before, whether you do it after, and maybe even in one project, you can apply multiple of these practices depending on the type of change that you're making.
Yeah, I think that's really cool. And I think it's important, one of the things that we've found in our research is that shorter lived branches tend to have better performance, right? You're making smaller changes more frequently, getting them into production. That's going to help across all 4 of those metrics. And this idea of, pull requests versus pair programming, certainly a pull request introduces some waste or some weight in the system, right? And so if we're pair programming and working together on a change, we're already introducing that 2-person review live as we go. As you said, context matters. So it's about finding the right balance and what works best for you and your team. But I think that this is really cool, and all of the tooling is here to support you.
Yeah, exactly. And again, it allows you, all of the tooling allows you to move on that spectrum between all of the different sizes that you have in the reports. All right, let's talk about the next thing that we have there, Marco. Let's maybe talk about CI/CD.
Yes, let's talk about centralized CI/CD and isolated builds. So if you open up the next slide, please, or when you rather, right. Centralized CI/CD, what is that point about? Well, think about, do you want your builds for your products to happen on the developer workstation on a Friday night? Or do you want them to be in a centralized place, essentially? And yes, obviously, you want them to be in a centralized place. Although I have to say that I also interviewed a couple of companies across the last year, and some of them did some builds on developer workstations. I have to admit it. So it's still a thing in 2022. But yes, obviously, you want to have a centralized place. Now, the thing is, think of JetBrains that we have dozens of products from desktop applications, our IDEs, to cloud services, from UTrack the bug tracker, teamCity itself, whatever. We want to have one big place, our teamCity CI/CD server, which builds all these products. And we like dogfooding, so that's why we built our own CI/CD server. It's called teamCity. We have just a couple of instances of that teamCity server, and you'll find every build of every IDE we have, of teamCity itself, of UTrack, every different version, every different environment you have, you'll find that all centralized in one big place. It is, and I'm not going to show it to you, our live teamCity server, because it's quite crazy to see. you basically lose the detail because you're so overwhelmed by that many projects. But in any case, dogfooding, our own CI/CD server, teamCity is quite powerful. And what I'm going to show you instead is we're just working on something which we call teamCity pipelines at the moment, which is, let's say, a slightly smarter version or more UX-friendly version of teamCity. And I'm just going to show you how you would, how pipelines that we usually build inside JetBrains look like. So if you could just share my screen, right? And no, not the pipeline demo, exactly my screen. So again, I mentioned that before, inside JetBrains, hundreds of projects, and I just put 10, I think, default pipelines here on my tiny server. And if you've worked with a CI/CD system before, I mean, there's nothing too surprising. What you want to see is when you open up a pipeline, you want to see, hey, what does the pipeline actually do? It builds a backend, it deploys a backend. It builds a frontend, it deploys a frontend. And at the end, there's some status being, messaged to some other system. And then, as Maarten already talked about, the history, you want to be able to see the history. How many runs have there been? Have they been green? How many tests have been run so far? When did the pipeline start? Were there any changes? How long did the pipeline take? All that sort of stuff, all visualized in one tiny place. And the same goes with editing, by the way. When you just click editing, you want, in a very simple UI, you just want to see, hey, My build backend box here on the left is my build backend job. On the right, I see what it actually does. I can see where it runs in the cloud on some Linux machine. How strong should the machine be? How many CPUs, gigabytes of RAM? What should it do? It's a Java project, Java Maven. Doesn't matter too much. It's just a couple of simple commands here, and then I can simply visualize my pipeline here. I can say, well, deploy frontend now shouldn't depend on build frontend, but rather on deploy backend. Doesn't make any sense, but I can still visually just rearrange my pipeline here, all centralized in one place. Now, this is a very simple pipeline. Imagine what happens once your server, bursts up and has hundreds of these pipelines. But that is why it's so important that you don't just have them running on some developer workstation where all these builds maybe influence each other also, and the previous build has some conflict with the next build you take. You always want to start with a clean slate for a whole pipeline, and that's what you get with a CI/CD server. Many choices out there, but teamCity and teamCity pipelines are, I would say, some nice choices that we use ourselves. All right, back to the slides, please. Let's see, what else do we have? Build script, right. So what I showed you so far is I showed you the UI configuration. And then again, we talked about, preserving history, seeing all the changes, what happens when, something is being built. And in fact, whenever you save something in the UI here, some text file is being written, some XML configuration as code is being written. Or what you could do is you could write that code yourself. We at JetBrains do with Kotlin code, and what you actually see here is a snippet of Kotlin code. And by the way, you could switch back to my screen again, and then I can show you this inside the IDE. I don't want to get into too much detail, but when you write your deployment configuration, your build configuration as code, well, first of all, while writing it, you have these obvious benefits, like, for example, the code is being compiled. So if there's a compile error, then you get error highlighting inside your build inside your IDE. You get auto completion inside your IDE. Then you can commit this configuration as code to your Git repository. In every point in time, you will see actually, yesterday, what did my build pipeline look like? What did it look like 2 weeks ago, 3 weeks ago? Who changed it? When did it change? What was the change? Who changed it? All this sort of information, just in a nice little text file. So I would say that's basically, for me personally, the biggie. I know there's a couple of wars going on. Is Kotlin the better language? Is YAML, for example, the better language? Again, I'm a bit, I'm leaning towards the Kotlin side of things. You can obviously also use YAML, many different formats. Important is that you track all these changes, that this is the truth, so to speak. So you look at this build pipeline script, and the only thing that happens here is you build a backend, it has a name, it executes a Java Maven step, it gets triggered by someone committing some code, and that's it. There's nothing else going into the build. That is literally your build's description, so to speak. And yeah. All right.
I think that's so important, though, to describe that as code, because that then becomes something that we can share with one another. We don't have to carry a bunch of mental context around. And as you said, because it's now code, it's in a repository, we have the history. And then, honestly, you start treating your pipelines just like you're treating your software, and we have to start measuring those same things. What's our throughput look like? How long does it take a change to go into production for our pipeline that's going to allow other changes to go to production for our customers? It all gets a little bit meta, but it all really comes together. And it's like those tools and capabilities that are helping you in one area are the same muscles and capabilities that you're going to use in another. So it really allows and encourages more experimentation and learning, and doing that iteratively as you go.
Absolutely, absolutely. I'd like to say that sometimes people can go too far. So if the build pipeline suddenly, the code is just a crazy complex architecture of massive amounts of code. But yes, there's always a nice middle ground where you can reap the benefits and not step over the board, so to speak.
Absolutely.
All right, then let's see. Oh, right, CI/CD at JetBrains. Well, so the thing is, just a quick summary. I didn't show you our live server, but I can tell you a bit about it. This is the bullet points you see on that slide is just they are just for the IntelliJ project, meaning that our IntelliJ IDE builds, basically, they consist of 87,000 lines of Kotlin configuration code, which is a fair amount of code. It's not just 10 lines of code, but actually, yeah, a fair amount of code. And when you think about it, what I mentioned earlier with the isolated environment, that you basically, when you run a build, start from a clean slate, go through the whole pipeline. We call them build agents. So, just servers running in the cloud, executing your build and producing, for example, the IntelliJ distribution. We have more than 1,000 build agents most of the time, doing builds, IntelliJ-related builds in the cloud. It's crazy when you see that for the first time. But yes, there's a fair amount of builds also going on at every point in time of the day. And that also leads us to, because, to the point of testing, I wrote that down here. Obviously, it's not just building the IDEs, compiling the code, and then building the distributable at the end, but also testing. Yes, we run a ton of functional tests per subsystem of the IDE that run on many different agents. Then we have these test aggregators where all the test results come together, and you see a big overview of what failed, where, when did it fail, and all that sort of stuff. And just in numbers, again, to impress you with numbers, we basically run 260,000 tests, over 200 builds running in parallel, which is, I find, also a crazy number. With, by the way, the testing, taking roughly an hour, total execution time, 50, 70 minutes. Yes.
Yeah, I think if you make a change on a particular subsystem, it actually builds and runs the tests for just that thing. But if you want, you can actually build an installer for a particular change that you are making. But I think the numbers also make sense because there's lots of different architectures, and you just want to be sure that everything works on Intel processors, on ARM, on older versions of Windows, newer versions of Linux, older and newer Mac OS, and things like that. So it kind of makes sense.
Yeah, there's a huge matrix of just the operating systems, different versions. It's endless, limitless, so to speak. All right. Yes. What we put in here is just, this is just a tiny glance. I'm actually I'm a bit sad. This is just, a tiny, what you can see at the bottom here, the second column, we compile idea trunk. And then the third column, you see there's some JavaScript tests running at the top. There's some Java tests running here, workspace, model smoke integration tests and whatever. And then Android plugin tests, debugger tests. It's just a tiny, let's say, viewport into the IntelliJ build universe. The actual build dependency graph chain is even bigger, but again, not to overwhelm you. This is just, a couple of lines, a couple of things that happen whenever you trigger an IntelliJ build inside our system. Right. Then we have something preventing inputs, parameters, metadata. Actually, I think I have something prepared for you when you go back right to my screen. So I'm back in teamCity. It's a slightly different view now. It's our current normal teamCity, but the same pipeline that we looked at earlier. But one of the points that is important, obviously, for every build that happens, what you want to do is you want to save a ton of data about that build. And I'm not just talking about data like when was it started, who triggered the build, what was the code change, but also all of the parameters that maybe went into the build. And as you can see here, what I have in my teamCity server open, the build backend, one of the backend builds I did executed earlier, I can see that I have some actual parameters on my build agent. So for example, this is all stuff that was installed on the build agent, what was installed, which version, from .NET to Firefox to Git to Gradle. So I can see all of that, what was happening, what was installed at the time of the build. By the way, I can scroll down here. Yeah, a huge amount of software installed, system properties, all of that. When I scroll up, I can see that I can also set user-defined parameters, obviously because users can or might want to influence builds. For example, here setting a secret key or with a value 1, 2, 3, 4. Now, what is important is, and teamCity and many other tools also offer that, is you have some sort of a role concept that You might have project administrators, you might have project viewers, you might have people that are only allowed to set certain parameters, not others. All of that sort of stuff. You want to basically manage those roles and the security. Then you want to, keep track of all the parameters. And so at any point in time, you basically have a pretty secure build pipeline. You know what goes into a build. You also know what comes out of a build, because we also save that information as well. All the artifacts that are being built, when they were built, where they were saved, all of that. So input parameters, output parameters, all being saved, secured with a nice tight role system, and you have a pretty nice pipeline project going. Right, which brings us back to the slides. And let me see if there was what the next slide was. SLSA Practices. I think it's
More
back to
SLSA
Maarten.
Practices. Yes.
It's back to Maarten again. Yes.
Yeah. One of the things that you want to do from writing code to actually shipping your code is also continuously doing code analysis and testing on everything you have. You want to see automatically whether the code quality is improving or deteriorating maybe over time. Maybe you want to see whether tests are passing, whether more tests are being written, or whether code may be untested going into the repository. So you want to keep track of all of that pretty much continuously. Now, of course, you would not be in a JetBrains webinar if we don't have any tooling for that. And of course, on the developer machine is where this all starts. Any IDE that we have and that you use has static code analysis available for you, where you're writing Kotlin or Java or .NET or PHP. You always have static code analysis rules that you can enable in the IDE. Now, all of the inspections that we have and all of the analyzers that we have a gradual severity. So some things are suggestions, some things are informational, knowing that you could do something different, for example. But we also have inspections that are errors and maybe prevent you, or you could actually configure the IDE to prevent you from committing when there's that type of inspections firing. At JetBrains, we have no inspections enabled for naming or formatting in IntelliJ IDEA. We do have close to 200 inspections that we have zero tolerance for. So that means we are actively monitoring and fixing whenever there's a red inspection on one of those 200s that we will not tolerate in the code base and will not allow to go to production there. But again, this is also a little bit of a spectrum where for your team, you have to decide what makes sense. I think we have good defaults, but depending on the type of project that you're building, the type of software that you're writing, maybe you want to enable or disable some of those static code analysis rules that are there. You also want to run all of these analyzers during CI/CD, and there's actually a new product called Qodana that we have, which comes with all of the analyzers and inspections that we have in the IDE. It runs, or it can run as part of your build that you configure in teamCity or in Space or whatever, and it will evaluate the integrity of your code and the dependencies that you have. So you will get reporting about what is going on in terms of code quality, and you will get better insights into whether the code base is improving and getting better, or maybe that regressions are popping up because some inspection is firing for the last week, for example, and you should be looking at this. So this is really helpful in figuring out whether your quality is actually getting better, improving, or not. So there's lots of analyzers in there as well. And again, just like the IDEs, you can configure what makes sense for your projects, but it does make sense to keep track of all of these aspects and information to have some insights in whether the software gets better or not over time. Right, and then there's a last aspect. It's one of the other practices that you can apply in your team, and that's operational analysis. There's only a couple of bullets on this slides. The idea is to monitor your software health continuously. When you deploy to production, when you ship to customers, when you deploy a mobile app, for example, to people using your mobile application, you want to keep track of exceptions, freezes, any type of feedback around performance that you may want to track. You want to have that, and you want to feed that back into the development cycle. There's tools like Qodana to give you dashboards. There's open telemetry if you're building services, for example, to get some more information about your product production server or production application. But the idea is that you continuously analyze what is going on in the software, and again, feed that back into the development cycle, maybe track whether performance improves or deteriorates over time, and handle that and actually make the application better over time. One of the things we do there at JetBrains is we use Exception Analyzer. So that's a custom system that we've built. We like building software. So that's why we have a custom system there. But the idea is that in the IDE, when you enable error reporting there, we keep track of exceptions that happen, maybe freezes that happen. We do some automated profiling and actually send the profiler snapshots there as well. We keep track of how the software is behaving, how it is performing. And thanks to preserving the entire history and some clever machine learning based grouping and assignment that we have in Exception Analyzer, we go full circle and we can actually find out who wrote a particular piece of code and which exception should be assigned to a certain developer in the development team, because they will know most about this specific subsystem that we have in the IDE. So that's, again, thank you to this practice of preserving history. We can actually keep track of what line of code, when an exception happens there, we can ping that particular developer or the developer that has been working on that file for the most in recent times. So this is how it looks. Nothing fancy. We just get reports there. We get issues logged. You will see the exception. And for every exception, you will also be able to see who was the developer. We automatically assign it. People can reassign it if it doesn't make sense for them to fix. But we do keep track of the operational aspect of even shipping the IDE. For Space, for example, for teamCity Cloud, we do this differently. But this is how we do it for the IDE. We keep track of exceptions and see what is going on there. So I think, does anyone have anything to add on top of that?
Sums it up nicely.
Yeah, I think it does. I think it does sum it up nicely. I think that, using the research, we can see that smaller changes that we can validate, that we can audit, that we have faith and trust that they are what we expect them to be. Seeing those smaller changes continuously moving through the pipeline and getting feedback on them faster and faster, that's the path to success. And context really does matter. So it matters where your team is today. You might not get everything tomorrow, but you can take a step forward. And it's embracing that practice of continuous improvement that is really going to pay off for you and your teams. So thanks so much.
Yeah, and again, context always matters, also in what makes sense for your team, but also for a particular piece of software. There are practices that exist. I think we covered quite a bit in this webinar. There's more in the report as well. And there's also tools that can help you adopt all of those practices that are there. Of course, speaking with the JetBrains hats, there's JetBrains tools. But if you look in the market, there's plenty of open source that you can apply. Even if you have like a one-person piece of software, there's lots of things that you can adopt in making that software better for you and your users in the end as well.
Absolutely. And I'd really like to thank everyone for joining us today as part of this conversation. And if you want to learn more about the report and continue the conversation with the community of practitioners and researchers that are putting this to work, please join us over at DORA.community, where we'll share, listen, and collaborate with one another more about putting this into practice.
That sounds good. All right. So again, subscribe there. There's more places that you can find information and subscribe as well. So we have the JetBrains website. We have Twitter accounts. There's the report as well, the State of DevOps report. Go there, read more about everything we've discussed so far and how it can help you make your software better. And with that, let's wrap it up. So let's say thank you for joining. If you did like this broadcast, give us a thumbs up. If you like more of these in the future, subscribe to our channel. And with that, again, thank you for joining. Thank you, Marco. Thank you, Nathen, for joining us as well. And we'll see you next time.
Thanks.
Thank you. Bye-bye.